All right, good afternoon, good afternoon. So we're going to look at some uniform circular motion problems. We're going to start with number 2 on the guided practice, and we'll also look at a couple more. So for number 2, Eva Destruction twirls a stone attached to a string 2 meters long in a horizontal circle. At what speed must the stone move for its centripetal acceleration to be equal to the acceleration due to gravity? So we know we have somebody, Eva Destruction. The hair's red.
Great, John.
You like that one? Alright, so we have a stone. We know this is 2 meters. And this is going to be twirled around. We want to know when is the acceleration going to be equal to 9.8 meters per second squared. We want to know what is that velocity. Alright, so we have an equation for acceleration. We also have some given information. We know the radius of the rope is 2 meters. The gravity is 9.8 meters squared. And we also have an equation. So we'll start with this equation, and then from there, let's isolate the v variable, velocity. The only thing that's attached to it is r, so I'll multiply both sides by r. Cancel, cancel. I'm left with r times ac is equal to v squared. I still don't have v isolated yet. It's v squared. So to get v by itself is squared, so I need to take the square root of that side, square root of this side. So then I'll end up with the square root of r times ac. That's going to equal to my velocity. And then I have some values. We know what r is. And then we also know what, we're back. So 2 meters, and then we wanted to know when centripetal acceleration is equal to gravity. So acceleration is going to be 9.8 squared. All right, and then now as we place this in, we're going to get square root of 10.6. This will be meter squared, second squared. And then if we take the square root of that, we'll just plug it into our calculator. So now we get velocity is going to be equal to 4.43. Square root of meter squared, square root of second squared is meter per second. And then I just want to make sure that this is a unit for velocity, and it is. All right, so that's number 2. So we know the velocity and or the speed that centripetal acceleration is equal to gravity. All right, so now we'll go to the next one. All right, so let's continue. We'll look at number 4 next. For number 4, the known formula is an airplane which is flying at constant speed. He has a radius of 5,000 meters. He's circling Jackson Hartsfield, and his period is going to be 400 seconds. And they want to know what is the speed of the plane and what is centripetal acceleration. So we'll go ahead and pull out our given information. So we know that r is equal to 5,000. Period is going to be 400 seconds. And they're asking us for velocity. And they also want to know what acceleration is. So for velocity, we'll go ahead and use 2 pi r over t. And for acceleration, we'll be using v squared over r. Right. So first thing we'll do is we'll just pull out the information. We have some airplane, it's circling, it has a radius of 5,000 meters. It takes 400 seconds for it to complete one revolution. So now we'll just drop that into the equation. So we'll have v equals 2 pi times 5,000 meters. Time is 400 seconds. And then put all this in. Get 3, 1, 4. I'm not sure what high is after that. 3, 1, 4, 8. Find out real quick. 3, 1, 4, 1, 6. 3. Then this will be in meters. 400 seconds. Drop it in the calculator.
Not even logged in. Just did not have. You're lying. Okay. I swear to God. So did everybody. So did everybody.
All right, so now we know what our velocity is equal to. And then now I'll just come in and place that in this equation here. So we have acceleration. It's going to be v squared all over r. R is still 5,000 meters. We get 61685. All right, and then now we have our acceleration value. So first thing is we want to solve for velocity. We'll use 2 pi r over the time. Once we get velocity, we can take velocity, place it in here, divided by r, v squared over r, and then we'll get our acceleration value. Awesome job. So next we'll look at number 5. Number 5 is an electron moves in a circular path with a radius of 0.1 meters at a constant speed. They want to know what's the period or its time for one revolution and what is centripetal acceleration. So we have some given information and we have some unknown information. So let's take it, put together and see what we can come up with. So here we have this one. I'm going to start with this equation. And from there, we can just rearrange this. We'll get the t up on top. It's on the bottom, so we can multiply it to the top. Cancel, cancel. And then the only thing now that's attached to the t is v, so we can divide that off. Cancel, cancel. All right, then from here, now we can just substitute. So we'll have 2 pi 0.1 meters divided by 2.0 times 10 to the 6 meters per second. All right, and then now that we have this values, we'll just go ahead and plug and chug in the calculator. So we'll drop all of these in there, and that should give us our value for time. Again, I'm watching my units, so to make sure that my units are good, everything needs to cancel out, and we'll be left with the. All right, so once we put all of that in the calculator, we'll get a value, and I also want to make sure that we'll get the correct unit as well. Meter cancel. Second flips up. Bottom of the fraction is always placed on the top. So now we know what the time is. So once we get our value for t, now we can go back in and find what acceleration is. So for acceleration, we're just going to use and then time. All right, and then also for this one, let's do a little cheater math. So I know that we can subtract these off. Positive minus a negative is going to be plus a positive. So that'll be 10 to the 13. Meters over seconds, that's meters per second squared. And then this will just be decimal here, 0.62 or something like that. So now we have the value for acceleration and correct units. So always make sure we have the correct units. And next one we'll look at is number 6. I'm not going to do the whole thing, but I'll at least set it up, and then that way from there you can figure it out. So we'd have some given information, but I'm already thinking about on this one, they want us to determine centripetal force. So first thing is we'll have our centripetal force equation. That's going to be an unknown. That'll just be the mass times centripetal acceleration. And they gave us mass and velocity in R. So we know what these values are. So I just want to get this equation in terms of this. So I know that for this one we can do mass times v squared over r. So this will be our v, this will be our r, and we have mass. Then we can find centripetal force. So from here you just plug and chug and you'll be good. All right, and then the same thing on this one. I'm just going to set it up, and then from there, just you'll have to make sure that you get it into the calculator correctly. So for this one, they want to know what is mass. So I'm already thinking I need that force equation. All right, then from here, the only thing attached to mass is centripetal acceleration. It's multiplied on, so I divide it off. And then now we have mass is equal to FC over AC. We just flip-flopped it. A equals B is the same as B equals A. We have a force, but we don't have centripetal acceleration, so this would just be force over E squared R. And then whatever's in the bottom of a fraction gets flipped to the top. And then we have all of these values. So we have V, we also have R, and we have force. So now we can just substitute in and we'll be able to find the value here. Just make sure you put in the calculator correct. All right, so those are some great notes for your test on uniform circular motion. And if you have any questions, just make sure you ask during class. Have a great day.